Go ahead and grab your data sheets. There might be extra copies floating around somewhere. I'm not sure where they'd be. I know I made more copies than we need. I made one copy for everyone. See the extra copies. I have a research question on the board. The question is, does acute head trauma lower IQ? Data taken from right here. Data taken from right here. Brooke, I don't see the extras anywhere. I had extras. I left them in this room. If you shoot me an email, I'll get a copy sent to you. Maybe you can pick, you can do, Spence can share one right now, perhaps.
Just out of curiosity, what is acute head trauma defined as?
How were they decided to define it?
Okay.
Michael, great question. Great question was, what is acute head trauma defined as? That is the rub in a lot of these cases, is how did you define the variable you're measuring? And again, that's where those research methods classes come in. Yeah, it's how we're putting faith in the fact that they defined it well.
Okay.
They defined it well, and we're trusting the data that we got.
Well, I know that. I was just asking for personal reasons.
Oh,
I've had a lot of head
exactly. Drummer of 30 years, myself as well.
Well played.
So the question I have is,
Wait, which page is
what do you think? It's on the very first page. Very first page. Okay, right there. I used to look at a lot of tests. IQ tests are designed to have a mean of 100, which you know. Okay, we're going to test at 95% confidence. The acute head trauma sufferers if acute head trauma lowers IQ. We're going to try this right now. Does acute head trauma lower IQ? What do you guys think? What do you guys think based on this data right here? What do you think? Gut feelings. I hear a no. I heard a no. There's a no. Ian saying maybe. Good. Christian saying yeah. Oh, I like this. Got all three answers. Maybe, yes, no. I'm hopeful that's no. I want all of you to quantify your results. In other words, tell me why you're voting as you're voting. See what I'm getting at here, friends? Yeah. Tell me why you're voting yes. Tell me why you're voting no. Tell me why you're voting maybe. Ian, go ahead.
Leaning more toward yes because there's only a few triple-digit results.
Oh, good.
Below 80s, 90s, 70s.
So what Ian is saying is, this is very good, my friend. He's looking at the data and saying, okay, on average they should be 100, right? They should be 100 on average. That's the mean for an IQ test. And these folks did average 100 before the acute head trauma. Now we're trying to see if there's a difference. Go ahead, Ian.
There's only 16 people with IQ tests around that.
Awesome. So I love this. So one way of testing this would be to make it, if you will, we can make this a one prop Z test. Let me clear this off. So one set of hypotheses we could do is we could put proportion, okay? Let's check the proportion. This is going to be the proportion of those with IQs. How do you want to do this? You want to do above 100?
100 or above.
100 or above? Sure. With IQs greater than or equal to 100 after head trauma. Okay? Well, we're doing it as a proportion, Michael, so that's basically going to be on average. Is that fair? Is that fair? So, proportion of those with IQs greater than or equal to 100 after head trauma. This is one way of defining it. I wasn't thinking of doing this, Ian, but this is cool because this actually ties right into your exam for Thursday. This is cool. There's another way of testing it too, but this is one way of doing it. So this is what we're going to be testing, that proportion. We got head trauma. They used to average 100, right? They used to average 100, so now we're going to see what proportion have an IQ greater than or equal to 100. So what are the hypotheses going to be? This is where it gets a little sticky, and this is where I'd like to maybe propose a second test besides this one. So here's the question. Assuming that the answer to does acute head trauma affect IQ, assuming that the answer to that is no, what should that proportion equal?
It should be greater than or equal to
What?
100.
Careful. This is a percentage.
Oh, 50.
50%. Half of the people should have IQs 100 or greater, shouldn't they? Think about IQ. It's a bell curve.
Gotcha.
100's in the middle. This part of the curve. That's half the curve. You see what I'm saying here, friends?
You mean where they lie on the curve?
I'm saying that half of them should have IQs over or equal to 100. The other half should be equal to or lower than 100. Think about the IQ curve, friends. Think about the IQ curve. Think about the IQ curve. 100's in the middle. This half of the curve has IQs above. This half of the curve has IQs below. So if we're testing it this way, I'm going with what Ian said about he noticed that there were only this many 3-digit numbers. I love it, Ian. I think it's a great idea. This would be the hypothesis we'd have to test. Is it 50%? Or if it actually is lowering, is it significantly less than 50%? Bob, going back to what you said, it should be that technically. Yeah? Now, this is not entirely obvious from this, but I wasn't going to test it this way. I was going to test it what you guys just said. We'll come back to that. We'll come back to that. Go ahead, Christian.
Is H1 success?
Well, define success. It's what you're interested in studying. So what we're going to see right now is acute head trauma lowering IQ as a percentage?
Okay.
Is it below 50%? Is the rate of those with IQs greater than 100 now less than 50%? It should be roughly equal to a 50%.
Is H not?
That's H naught is that it should be half and half, 50-50. We're trying to see if it's lower or greater or higher. But I mean, it sounds like what Ian's saying is he's leaning toward the other way. Because what you counted. I love it. You looked at they did it and said it looks like there's too few up there. I like that. Paris.
I'm so confused. Why isn't it P bigger than?
Because Ian's claim was that there are too few triple-digit numbers. There are too few numbers up here. It should be 50%. He's not getting near 50%. That's why. Yeah? Follow with me here, friends. Follow with me here. Follow with me here. Let's test the data. Let's test the data. Okay? So now we're going to run a Prop Z test against 50%. Ian, you said you counted them, correct?
Yeah, I got 16.
16, good, out of 61?
Yeah.
Good! 16 out of 61. Love it. So the reason Ian is saying this is he looked at all the data points. Of all the data points, they averaged 100 before. Now, of these 61 data points, only 16 of them are 100 or greater. If there was no change in IQ, it should have been half, roughly 30 of the 61. In that neighborhood, in that plus or minus with the margin of error, which this will calculate for us.
I think there's only 15.
Only 15? That's fine. 16, 15, that doesn't bother me as much. Because I'm pretty certain that when we test to see if it's going to be lowered, it's going to be ridiculously lowered. Is it lowered?
Oh, yeah.
Oh yeah, 0.0001. That's a tiny p-value. Look at the number of standard deviations, friends. We're almost 4 standard deviations below where 100 is. We've got 16 out of 61, right? 16 out of 61, that's like 25%. We should be at 50%. We're unfortunately at 25%. That's nowhere near the percentage we should have above. Now, that's one way of testing the data. I wasn't going to do it that way. I wasn't going to do it that way. I was going to test what Bob implied. I think Susie and Bob both implied another way of testing. This is one way of doing it. But I think what these guys over here were talking about testing to answer the same question. Here's an alternate way of testing. Rather than, I think the 50% is throwing you guys through over there too. So let's ignore the 50%. Let's try to see, rather than looking at the percentage above and below some arbitrary value of 100, why don't we look at the scores themselves?
Right.
How about that? I think that's what you guys were saying, right?
That's what I was
So you're saying if head trauma, that's trauma, isn't lowering IQ, then the average of that group should be what?
50%.
Should be 100. Well, it is a percent, actually. It is definitely a percentage, but we don't usually call it 100%.
That's what it was in the beginning.
Right, it was in the beginning. Their IQs were 100 in the beginning. If head trauma is not changing that, it's still going to be 100. But if head trauma is lowering IQ, what's their average going to be?
Less than.
Good, just less than 100. How much less?
It doesn't matter.
Put a word in there.
Significant.
Significantly less. That's it. I don't want to quantify how much less. Confidence intervals will do that for us. So your one-sided intervals will do that for us. But I just want to see, is it significantly lower? Is this data showing that it's lower? This analysis over here showed us that as a percentage, we have too few people above 100. But is the IQ score itself lower? Go ahead, Christian.
How do we define significant? Like, is 10%?
Hold that thought. Hold that thought, Fred. Hold that thought. We're getting to it. I promise. We're getting to it. That's a great question, and we're almost there. But I have another question before we get to there, though. How would we test that using a 1 prop Z, like we did over here? And it's a bit of a trick question. It's a bit of a trick question. How could we test that using a single proportion hypothesis test like we did over here? And it's a bit of a trick question. You can't. Because what am I asking you to test over here? An average. What were we testing over here? A percentage or a proportion. Very nice. Proportion, average. This is starting to sound like something from your first exam. On the first exam, sometimes you built confidence intervals around proportions, and sometimes you built confidence intervals around averages. This is the same disconnect here. To continue pursuing this awesome connection with the first bit of the exam and confidence intervals, this is the next series of connections. So here's where we're headed, friends. Let's turn this off. Let's turn this off. Swing over here. We are now beginning the next part of this. Make sure you guys can see this okay. So, we're smack dab in the middle of hypothesis testing. I think we're pretty happy, well, content, with testing a single proportion, which we're calling little p. That's what will be on your exam Thursday. 1 prop Z test. 1 prop Z test, right? We now need a tool to test a single mean, which we call mu, our average. Exactly, a single average or a single mean, which we're going to call mu, which means our hypotheses are going to look a little bit different, aren't they? Our hypotheses are going to look a little bit different. They're not going to have little p's in them. They're going to have little mu's in them. They're going to have little mu's in instead of little p's. That's the difference. Michael?
Well, that's the thing. That was my problem with the other test, is that it didn't take into account all the scores above and below.
Well, it did by a percentage basis. What it assumed was, if you have a series of IQ scores, they should be equally distributed above and below average.
But that assumption is wrong.
Is it wrong? Why is it wrong?
Well, because essentially, if you're looking at the 100 scores, the 100 scores may be exponentially higher or exponentially lower above 100 than the scores below 100. In other words, if all the scores below...
But here's the deal, though. Here's the deal. I love what you're saying, Michael. You're correct. You're talking that way.
Right.
Percentages don't care how far above or below the distance they are.
Okay.
So it's the difference between a median and an average. Think about it that way.
Okay.
The median doesn't care how far above the middle point you are, just that you're above.
Okay.
That's what Ian was testing. What you're saying is 100% correct.
Okay.
What I'm saying is this test doesn't care, or this test didn't care about that. It just cared where you were, left or right of 100.
Okay.
This test has a little bit more refinement. So this is the difference between, we did the same thing, oh my God, 3 weeks ago. Del Taco, half pound bean and cheese burritos.
Oh, yes.
First, we said what percentage were above a half a pound. And then we went back and calculated the actual average weight of the burritos. Same thing. What percentage are above 100? Now, what's the actual average? It's the same exact idea. And you're correct. You're correct. This one doesn't care about the distances. That one will over there. Fair enough? Good. So let's rewrite these hypotheses. These hypotheses are exceptionally wordy, aren't they? Lane. What up, Lane? Let's just do this. Let's define the variable. These are both going to have a mu on them now. Yes. We have a mu now. What is mu going to stand for? It's the average score, IQ score, of head trauma sufferers, acute head trauma sufferers. Exactly. It's the average IQ of acute head trauma sufferers. Did I spell that right? Sufferers. It's a lot of R's. What would you like to test? That it's going down, that it's going up, that it's staying the same? What do you guys want to say?
Different.
That it's different? You want to test that it's different? I love that idea. We're going to test that it's not 100 anymore. I love this. It's a two-tailed test, which means to see if we can test it as a confidence interval or a hypothesis test. We'll do it both ways, of course. We'll do it both ways. What should the null hypothesis be then? That it just equals. Now, does it mean literally exactly equals 100? No, it means within a margin of error of 100, defined by the data in the research study. Yes. Cool? Okay, friends, first, if you will, construct for me a two-sided confidence interval around this data. I'll stop right here so you guys have time to put data in your team.